Okay, so from that list that you have in front of you, you have this table that explains your precedence table. And what the precedence table is it just shows you a list of activities that need to be completed to complete a task. So the sheet that you have in front of you is what we do to make a cup of tea. So you'll notice that on my table on the board, I don't have the names of the activities, I've just got the activity label A, B, C through to G. The second column is your time. Now generally, when it comes to precedence tables, your duration is in time. And another name for your duration is what we call your weights. Now we'll get to that in a second after we draw a network table. But what I want you to do on your table right now is, if you can add on an extra column called prerequisites. The prerequisites is what's going to dictate how our diagram is going to flow when we show the information from our precedence table into our precedence network. So if we have a look at your table with you right now, a prerequisite is when an activity requires another activity to complete before you can actually start. So for instance, if we look at your table that you have in front of you, you need to retrieve the cups. Do you need to do anything else in that list first before you retrieve the cups? In this instance, it's a no. So by putting a dash there, the dash means that that task requires no prerequisite, so it's an independent task. If we have a look at the second activity, which is place tea bags in the cup, well, in order for you to be able to complete that activity, you need to have the cups already. So therefore, B requires A as a prerequisite before it can be started. If we have a look at C, which is fill the kettle with water, again, that's another activity that you don't need to rely on before it can start. It can start independently. So C can be given an independent stroke. Looking at D, boil the water and put it in the kettle. Okay. In order to boil the water, you need to have the kettle, and you need to have the water in the kettle. So therefore, D relies on C to complete. This next one is interesting. If we have a look at it, E, it says, pour the boiling water into the cups. One would assume that you would need to have activity A. You'd also need activity B, you need activity C, and you also need activity D. However, when it comes to precedence tables, we're only dealing with the immediate prerequisite. So in this case here, we don't need A and we don't need C. And the reason why we don't need A and C is because we're already relying on B to be completed before we can start task E. And task B is already relying on A. So the immediate prerequisite of E would be B. And the same thing goes for D. Because we're relying on D to be able to do part E, we already know that D is relying on C. So therefore, we don't have to rely on C in this part because it's not the immediate prerequisite. So in this case here, the only prerequisites for D, for E would be B and D. We then have a look at the next one for F. F is add the milk and sugar as necessary. Now we're assuming you make a cup of tea this way. So F relies on E, and the last one, stir your cup of tea, G relies on F. So what we have here is your prerequisite column. And it's this column here that's going to help us dictate what your network or the flow of your network and how the connections are going to be put together. So let's do that now. On your list of information I've sent to you, I've said that we have something we call a source node. Now this here is your source node. Your source node is the beginning node of your network. And it's from this node here that any activities that are independent become activities from that node. So in this case here, we have two activities. We have activity A and we have activity C. They're both coming from the starting node. They don't have any prerequisites, so they come from there. What I would suggest you do at this point is don't end any of these nodes until you know there is no dependence on it at all. So if we have a look at this next one here, we've done these two. we now can start looking at any prerequisites. B needs A to finish first before it starts. So to finish an activity, we put a node there and we say, well, let's bring B out. And let's write B here. A note that I want you to remember at this point here is make sure you're doing these networks in pencil, because there could be a chance where you're going to have to change the look of the network itself. So in this case here, we've done B. We now come to D. Now D's relying on C, so we can finish C here and bring D out. Again, notice how I'm not ending these because there could be a chance where I might have to fix them up a little bit. So I can click this one off here. Now this is the reason why we need to make sure we do these in pencil, because you may have to erase it. E is relying on both B and D to finish at the same time. Here I've got them separate. So what I can do is I might just rub these out and say, well, I know they need to come together, so how about I just bring them together like this. Still call them D and B. And we end that node because once B and D finish, E can now start. We can finish E when we know there's an activity that relies on it. In this case, F relies on E to finish first. So we finish E, we bring F out. Again, we look at the next one, G relies on F. So we finish F, bring G out. And the last part we need to do at any activity is put your sync node in. So this here is the precedence network that represents your prerequisite of the precedence table. One thing that we're going to add into it now is we're going to add in your weights. Now your weights, remember, is the time that each activity takes to complete. Okay, so the weights is the time that each activity takes to complete. And we generally write these numbers up on your networks next to the letters, the activity. So in this case here, we'll put 15 next to A, we'll put 10 next to B, 20 next to C, 100 D, 10, 15, and then 10. We need those because we now need to calculate what we call the critical path. Now the critical path is the longest path, or the critical minimum time is the longest path taken from start to finish. So in this case here, we've got two paths. We've got A to B to E to F to G. Another path would be then A to C to D to E to F to G. So we've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So take it back, it's C through to E. So they've both got 5 in each case. In this time when we're looking just with precedence tables and networks, what we're looking for here is we're looking for then the longest time it's going to take, because we want to have the earliest finishing time. So in this case, if we look at this one here, we've got 15, 25, 35, 50, 60 seconds. Where this next one, we've got 20, 120, 130, 140, 150.